Hey guys, welcome back. So this is part 2 on this smoking Briggs engine. And as you can tell, part 1 didn't go so well because it ended in the complete disassembly of this engine. But this was a 10-horse engine that came on a Craftsman generator. The generator started and ran, made power, and could support a load. It did just fine under a 3,000 watt load, but it was smoking, and I thought I heard knocking as well. So this engine definitely has issues. While troubleshooting, I thought I discovered the issue, which was a damaged head gasket. So I replaced that, put it back together, but the smoking was just the same. So tore the engine down, half expecting to find a stuck or broken ring or one that was damaged in some way, but I didn't see that at all. I mean, this ring is good. As far as I can tell, there's no defects. And the ring end gap was dead on. I think more likely the issue has to do with the cylinder. Although it measured up fine, there is some scoring. And I think that scoring is contributing to the smoking. Whether that's the only thing, I don't know. I am still suspicious of these rings, so I ordered a new set of rings. I'm going to hone that cylinder, and I'm also waiting on some gaskets and oil seals. So while that stuff's on their way, I want to prep this block the best that I can, get the cylinder honed, ready for the new rings, clean up all the old gasket material. And then we'll put this thing together and try it out. So let me get it set up a little bit better and get going on this thing. So there's an up-close look. Came out pretty well. You can still see the lines just a bit, but they cannot be felt anymore. So that should work out just fine. I did check with the bore gauge as I was honing, just to make sure I wasn't removing too much. And, I'd say in total, I probably honed for about 2 minutes, maybe a little more, and about 1,000th of material came off. So we're still within spec, but it definitely can't be honed anymore. If it gets damaged again, it's going to have to be overboard. So I got most of this gasket material off with a razor blade. It's really stuck on there. There's really no better way to do it. Generally, you want to stay away from using a razor blade, especially on the head. But in this case, there's no other way that I know of. Anyway, now that that's off, I'm going to hit it with the 3M plastic Rolock brush, and then finally a bit of Scotch-Brite. Okay, all the parts are here. We have the head gasket, a couple oil seals, the sump gasket, and the ring set. Now, believe it or not, it's actually been almost 2 months waiting for those rings. The first place I ordered from said they had it in stock. After a month of waiting, I canceled that order and ordered somewhere else. But yeah, that was still pretty slow. So I wasn't really prepared to store this for so long. I've fixed quite a few things since the first part of this video. Anyway, I'm going to get the rings out. I'm going to check the end gap, and if everything's good, we'll start putting this engine together. Yeah, that end gap is fine. Briggs says anywhere above 8 thousandths up to 30 is standard, and you can go all the way up to 60 thousandths. In this case, I just checked with an 11 thousandths feeler, and it fits fine. So there's no issues here. I'm just going to check the ring end gap in the middle, as well as the bottom. That's fine. And that's fine. So I'll do the same check for the rest of the rings and turn you on in a second. Yeah, all the rings checked out fine, and I never really explained why we have to check this, but if the gap is too small, what happens is when the engine heats up, that gap will shrink even more. And if it closes up completely, the ring starts pushing really hard on the cylinder walls, and eventually either the ring will break or you'll damage your cylinder. Now, an end gap too big isn't going to cause any damage per se, but it is going to let oil through, it's going to let compression through, and the engine's not going to run as well. So ideally you want the gap as small as possible, but not too small. All right, we'll get this expander installed first. It's a little bit different than most. This copper wire goes right in the center here. Like that. All right, for the oil control ring, this one's a little different. That expander I just installed kind of goes into this channel in this ring. So once the ring is installed, we'll just double check that the expander is kind of properly in that channel. Yeah, I don't know why they use blue, but they do put marks on these rings. So the one with 2 marks, that's the second ring we want to put on. And then the top run, the compression ring, has 1 mark. You want to make sure these are to the right when you install it. Yeah, just make sure you stagger these end gaps. I have one here, here, and here. It doesn't really matter. You just don't want them to all line up. All right, sorry about that. I think you missed it. Anyway, this seal has been installed. I'll show you on the sump cover how to install that. All right, ready to get the seal onto the sump cover. And for this one, it's a little bit more difficult because you do have the governor gear as well as the oil sensor. So you do have to support it on the sides so you don't end up crushing and damaging any of that. Anyway, as far as the install goes, it's fairly straightforward. I am just going to use a socket to put around the seal to drive it in. And this has a lip, so you really can't drive this one in too far, but you do want to be careful. Not all have lips like this, because if you drive it in too far, you'll end up covering this oil return. And if you do that, it's gonna lead to problems. So just be sure before you remove the seal to take note of how far it was driven in. Yeah, that should do. All right, and pay attention. When this was assembled, the arrow should be pointing towards the flywheel, and this should agree. It should say mag. The other side says PTO, which is the generator side. So make sure everything is in agreement. So this here is the crank that came out of this engine, and it doesn't look great. I mean, there's some marks, some scratches, but before ordering the parts, I wanted to double check this crank. I did hear at times what I thought was knocking, and it definitely was knocking. This is a bit out of spec. Not terrible, but it is about 0.02 from the new size. So that is out of spec. Ideally, it would be 1.2475. And we're more like at 1.2465. So, yeah, that's not great. I do have other cranks, none of them perfect, but this one I think is better. You can tell by looking at the journal, it is much cleaner. It's not perfect though. There are some nicks on it, but I don't think that's going to affect anything too bad. And more importantly, when you measure it, it has about 1,000th more material. So that's going to make a big difference. You know, I did check in 3 locations in this direction and 3 on the other. But we're at 1.24745, and that's a lot better. So I'm going to go with this one instead. And as far as installing this bottom piece, there's a few things to take into account. This hole here is where the oil gets splashed and goes to the journal on the crankshaft. You can see it's not centered, it's more to the right. That's how you want to install it. Also, the dipper goes on this side, and you can see one side of this dipper is flat and the other one is cut at an angle. So it's the angle side that goes up against this piece. And I guess the last thing to note too, this piece here, you can see one corner is cut differently. That corresponds to the back right side of this connecting rod if you have everything installed properly. Connecting rod should be tightened to 100 inch-pounds. I'm going to bring it up to 60 first, and then I'll finish it off. Timing marks are right there, and that should correspond with the dot on the cam. A lot of people ask about the governor. They don't see it here and they're wondering where it is. It's actually on the back of this cover. It's right here. The way it works is the faster the engine spins, the more force is applied to these weights. And the more force, the harder this pushes out. And it doesn't move much. I mean, it's probably less than 1/4 of an inch. But it's that piece there that pushes against here to slow the engine down. It's connected to the carburetor, the throttle plate specifically. So when you shut the generator off, there's no force trying to close that throttle. So the governor spring, which is on the top of the engine, pulls the throttle to full open position. And I see a lot, especially on these things that sit around for years, that throttle on the carburetor can stick open so that when you start the generator, even though this is pushing very hard trying to close that throttle plate, it can't do it, and your engine will overspeed. So if your engine's running too fast, it may not be a broken governor. Definitely check your throttle plate manually to make sure you can open and close it. Okay, so I got the engine rotated just a touch past top dead center. And, I put the tappets and the push rods back in the same spots where they came. So theoretically, the valve adjustment I did earlier is still good. But if there's any difference in the thickness of the head gasket, then I may have to readjust those valves. And on this engine, anywhere between 4 and 6 thousandths is considered good. So let's check 5 on the exhaust. It's loose. 6 is loose. 5 on the intake. Tight. So we've got to readjust the valves. And make sure you put the coil on the right way. This one's actually labeled cylinder side. So that goes like that. If you do it upside down, you're not going to get a very good spark. And even if you do, the timing's going to be off. So make sure you put it the way that it was. Yeah, don't have a torque spec on this. I'd say it's at least 100 inch-pounds. You could probably go up to probably closer to 160, 180. Do 140. Briggs recommends 180 inch-pounds for the exhaust. Give or take. Okay, ready to give this thing a try. I got the fuel hooked up. I did move the spring over one hole just to take some of that tension off. I don't want it running at full speed right now. You know, that said, it'll still run at about 3,000 RPM. Now, I do expect this to smoke a little due to the assembly lube, but that should burn off very quickly. So let's give it a try. Quite a difference. There's no smoke whatsoever. So I'd say the smoking issue is fixed. You know, the carb, actually, I'm not so sure about. I haven't cleaned this carb. Actually, the guy I bought it from cleaned it, but it's not running the engine quite right. But that's an easy fix. So I really just wanted to make sure that the engine's no longer smoking, and it's not. So we'll get the generator head back on. We'll get most of this back together and do another test. All right, I'm going to use thread locker on the bell housing bolts and torque it down to 20 foot-pounds. And the rotor bolt, I'm going to torque down to 23 foot-pounds. But before I can do that, I do need to lock the engine up. So I'm going to pull the spark plug. We'll get the piston at the bottom of the stroke. We'll fill the cylinder with rope, and then we can torque down on that rotor bolt. This broke. So I'm going to pop the rotor off, see if we can't get the broken piece out of the crankshaft. Otherwise, we might be starting back at square one. Okay, this bolt should not be stuck, so I'm going to try tapping it, and hopefully that works. Otherwise, there's a few other things we can try. Well, that's a first. I've never broken one of these bolts, torquing it down to 23 foot-pounds, so potentially there was something wrong with the bolt. I know 23 foot-pounds is right on the edge of what you would want to tighten this to. So I think going forward, I am going to be torquing this probably closer to 20 foot-pounds. Anyway, I checked my stash. I have no bolts that are the right size, so I already went online and ordered a new bolt. So that'll be here in a few days. And as bad as this is, it could have been a lot worse. I mean, this piece thankfully came right out, and the threads on the crank are fine. So, you know, if that crank had stripped out, we would have been in a world of hurt. All right, I'm the proud owner of one new rotor bolt. So we'll get that installed. You know, as far as the old one goes, unfortunately, they don't mark these as far as what grade these bolts are. I was assuming they were at least a grade 5 bolt, but given that it snapped, you know, now I'm not so sure. Anyway, we'll tighten that one down to 20 foot-pounds. All right, now's a good time to get the rope out of the cylinder. I'm going to pull the engine over with the spark plug out. Just make sure the engine spins freely and that I don't hear or feel any contact between the rotor and the stator. Sounds good. All right, the two sets of wires I just plugged in are the DPE winding and the sense winding. In this case, I'm not sure which is which, but make sure you get them on the right sides. The one with the 90 degree here was on the right, and the other on the left. Also, it looks like there is a potentiometer here, so we can adjust the voltage if we need to. And the only other set of wires coming out of this AVR are for the brushes. So the black wire is positive. That one goes on toward the back, and the white on the front brush. All right, and that's pretty much it for now. I'm going to leave this cover off the engine so I can adjust the speed, and I'll leave the stator cover off as well. This piece here that I put on, a lot of people don't know this, but this actually takes hot air that's coming out of the engine and recirculates it into the carburetor. So it's something you usually don't want to run in the middle of the summer on a hot day. But the idea is when it's cold out, especially when it's below freezing, this sends warm air through the carburetor to keep the carburetor throat from icing up. In warmer weather, it's just going to serve to make the generator run hotter than it would otherwise. All right, mostly ready to go here. I have to move the governor spring back to its original position. I want this to run at 61.5 hertz. Also the carb, gonna leave it alone for now. This carburetor was doing a good job before I took the engine apart. And the last time I tested it, the rotor was not installed. And the rotor actually accounts for more than half the weight on that crankshaft. So potentially that is why the engine was a little bit off. So we'll give it a try like this and see how it sounds. Okay, well the engine speed is good, but the voltage is low. So there is an adjustment here on the potentiometer on this AVR. So I'm gonna adjust that. I don't know if it's clockwise to bring the voltage up. Usually it is, so I'll give it a half turn clockwise, see if it's any better. All right, not too bad. The voltage is now at around 121, 122 volts. The engine speed was a bit fast, so I pulled it back a bit, closer to 61.5 hertz. I think I actually ended somewhere around 61.7. And as far as I can tell, that battery is charging, so I think we're good there. Really, the only follow-up is this switch. The first time I started it, I went to shut it off and realized it was actually already off and the engine was running. So The switch wasn't working. I did try touching this black wire, which goes to the coil, to a ground, and the engine kept running. So either we have a bad wire, or potentially I didn't hook it up to that coil. You know, otherwise I'd say this thing is pretty much done. So I'm gonna get the end cover back on the stator. I think I'll just pull this cover off real quick and get a closer look at that wire. Well, there's your problem. I thought I plugged that in, but yeah, maybe not. All right, gonna start it up one last time. Make sure that switch can actually shut it down. All right, well, that's pretty much it. I mean, everything's been fixed, and this thing's doing what it should. So I hope this video helps someone. Thanks for watching.